You know, whenever we're building system integrations, there's always that one big worry. What happens when things go wrong? Well, today we're going to look at a powerful safety net for your data, a tool that's really designed to make your integrations incredibly reliable. So, picture this. You've got a perfect data flow humming along between two systems. But then, bam, the receiver system just goes down. What happens to all the messages that were on their way? Do they just vanish into thin air? Yeah, in a lot of cases, that's exactly what happens. Poof! They're gone. A little temporary system hiccup can actually lead to permanent data loss. We're talking lost orders, missing customer info, stuff that has a direct impact on the business. And that is the critical problem we're here to solve today.
So this brings us right to a classic challenge in the world of integration, what I like to call the fragile connection problem. It's all about how directly systems are linked, which, as it turns out, creates some major vulnerabilities.
See, when a sending system is directly or tightly coupled to a receiving system, it's kind of like a phone call, right? If the person on the other end hangs up or their phone dies, the conversation is just over. The sender needs the receiver to be online, ready, and waiting at all times. And that kind of dependency creates a massive single point of failure.
All right, so how do we fix this? The solution is all about a principle called asynchronous decoupling. And the whole goal here is to break that fragile, direct link between the sender and the receiver.
The easiest way to think about it is like this. Instead of trying to hand a package directly to your neighbor, what if you could just place it in a super secure mailbox? Then a really persistent mail carrier takes over. They're responsible for delivery, and they'll just keep trying, over and over, until your neighbor is finally home to get the package.
Okay, so let's see what that looks like in the real world. In the SAP Integration Suite, that digital mailbox is something called a data store. So the first integration flow doesn't even try to send the message to the final destination. Nope. Instead, it just writes the message safely into this data store. And at that point, the message is secure. And here's the really crucial part. The middleware, that's the integration platform sitting between the two systems, it takes full responsibility for that message. The original sender doesn't have to worry about a temporary problem or even know it happened. The middleware stores the message and handles all the retries all by itself.
So the concept makes sense, right? But how does it actually work? How does that message get out of the digital mailbox and to its final destination? Well, this is where the data store sender adapter comes into play.
It's actually a really elegant two-flow process. First, an inbound flow gets the message and just writes it to the data store. That's it. Its job is done. Then, a completely separate outbound flow, which is kicked off by our data store sender adapter, is constantly checking that store for new messages. When it finds one, it tries to deliver it. If it fails, no big deal. It just waits and tries again later.
Now, what's really cool is this built-in safety feature. In a high-performance system, you might have multiple servers or worker nodes all processing messages at the same time. The platform guarantees that two different servers will never, ever pick up and process the exact same message. And that is absolutely crucial for data integrity.
Now, the best part, you have a ton of control over this whole process. You get to fine-tune the schedule, how it retries, and even the scope of the adapter. So let's take a look at the key settings you can play with. When you go to configure this adapter, you basically get this whole control panel. These options let you define all the rules for your digital mail carrier. Everything from naming the mailbox to deciding just how aggressively it should try to deliver a message. So, the first big choice you have to make is visibility. Do you want a global data store that can act like a central mailbox for a bunch of different integrations? Or do you want a private one, just for a single integration flow? This is a pretty fundamental design choice, though honestly, keeping it specific is usually the safer way to go. So, when a delivery fails, what's the next step? Well, by default, the adapter just waits 1 minute before it tries again. That's the retry interval, and you can configure it to be anything from 1 minute all the way up to 24 hours. And this is where things get really clever. There's a feature called exponential backoff. If you turn this on and the first retry fails, the adapter automatically doubles the waiting time for the next attempt. So 1 minute becomes 2, then 4, then 8, and so on. This is brilliant because it prevents your integration from hammering a system that's already struggling to recover. It gives it some much-needed breathing room.
And finally, we have the lock timeout, which is this really critical fail-safe. When the adapter picks up a message, it locks it so nothing else can touch it. But what if the integration server itself crashes in the middle of processing? Well, this timeout makes sure that lock gets released after 10 minutes so another server can pick up the message and try again. So let's zoom out. When you combine all these different pieces, what's the big picture here? What do you really get? Well, you get more than just a clever technical trick. You get resilience. You get integrations that you can actually trust.
The official SAP documentation just nails it. This whole pattern lets you achieve a quality of service called exactly once. And let me tell you, that is the absolute gold standard for enterprise messaging.
And what exactly once means for the business is actually very simple. It means no lost data during an outage, and no accidental duplicate messages when the system finally comes back online. It's a guarantee that every single message will be processed completely and correctly one time, and one time only.
So as we wrap this up, I'll just leave you with this one question to think about. Which of your fragile, tightly coupled integrations could really use this kind of resilience? Because by putting a pattern like this in place, you can build systems that aren't just functional, but are truly, truly robust. Thanks for tuning in.